A strange star near a black hole is defying expectations. Astronomers have found a star that shouldn't exist. It's orbiting a dormant black hole in a system called Gaia BH2, about 3,800 light-years away. And when scientists listened to its song, tiny vibrations rippling through the star, they discovered something impossible. This red giant looks ancient, but it's actually young. It's spinning far faster than it should, and its chemical makeup suggests a violent past that challenges everything we thought we knew about how stars evolve. Welcome to the mystery of Gaia BH2's companion star, a star that breaks all the rules. Stars aren't silent. They vibrate. Just like earthquakes reveal Earth's internal structure, starquakes, oscillations that make a star's brightness flicker subtly, reveal what's happening deep inside a star. Using NASA's TESS satellite, Transiting Exoplanet Survey satellite, astronomers detected faint starquakes rippling through the red giant companion of Gaia BH2. These vibrations allowed the team to measure the star's core properties with remarkable precision. Just like seismologists use earthquakes to study Earth's interior, we can use stellar oscillations to understand what's happening inside distant stars, said Daniel Hay, lead author of the study from the University of Hawaii Institute for Astronomy. These vibrations told us something unexpected about this star's history. What they found was shocking. The star is packed with heavy elements called alpha elements, chemical signatures typically found in ancient stars formed when the universe was young. Based on its chemistry alone, this star should be about 10 billion years old, but when scientists studied its internal vibrations, they discovered the star is only about 5 billion years old, half the age its chemistry suggests. Young alpha-rich stars are quite rare and puzzling, Hay explained. The combination of youth and ancient chemistry suggests this star didn't evolve in isolation. So, what happened? Here's where it gets even stranger. Long-term observations from ground-based telescopes show the star rotates once every 398 days, far faster than an isolated red giant of its age should spin. Stars slow down as they age, losing angular momentum. A 5-billion-year-old red giant should barely be rotating at all, but this one is spinning rapidly. If this rotation is real, it can't be explained by the star's birth spin alone, said co-author Joel Ong, a NASA Hubble Fellow at the University of Hawaii. The star must have been spun up through tidal interactions with its companion, which further supports the idea that this system has a complex history. The black hole's gravity is pulling on the star, creating powerful tidal forces that have spun it up over time. The most likely explanation? This star didn't evolve peacefully. Astronomers believe it either merged with another star in the past or absorbed massive amounts of material when the black hole formed from its previous companion. When two stars collide and merge, the resulting star can appear younger than it actually is. The merger resets the clock, mixing fresh material and changing the star's internal structure. It also transfers angular momentum, causing the merged star to spin faster. The alpha-rich chemistry? That likely came from the companion star it merged with, or from material it stole during a close encounter. This star's strange mix of youth and ancient chemistry is a fossil record of that violent event. What makes this discovery even more fascinating is the black hole itself. Gaia BH2 is a dormant black hole. It's not actively feeding on its companion star. It's not blasting out X-rays. It's just there, silently tugging on the star through gravity alone. These quiet black hole systems are incredibly hard to find. Most black holes are discovered, because they're actively feeding, producing bright X-ray emissions. But dormant black holes like Gaia BH2 were detected only through the subtle wobble they cause in their companion star's motion, a technique pioneered by the European Space Agency's Gaia spacecraft. Finding them is like searching for invisible gravitational anchors scattered throughout the galaxy. The Gaia BH2 mystery. The research team also studied Gaia BH3, another dormant black hole system located just 2,000 light-years away. This system is even stranger. The companion star in Gaia BH3 is extremely metal-poor, meaning it has very few elements heavier than hydrogen and helium. Theory predicted that such stars should show clear oscillations in their light, but when astronomers looked, there were none. No starquakes, no vibrations. The result was baffling. This unexpected result suggests that current theories about stars with extremely low metal content may need to be revised, the researchers noted. It's a reminder that even our best models of stellar physics are incomplete. The discovery of Gaia BH2's bizarre companion star opens a new window into understanding binary star evolution, especially systems involving black holes. Dormant black hole systems are quieter, less violent, and may preserve evidence of stellar collisions that more active black holes would have erased. If stellar mergers are common in these systems, it means the stars we see today might not have evolved alone. Many could be the result of violent cosmic collisions we can only detect by listening to their vibrations. Future TESS observations will provide longer data sets, potentially confirming the merger hypothesis and revealing whether other dormant black hole companions harbor similarly violent pasts. This star shouldn't exist, not with this combination of youth, ancient chemistry, and rapid spin, but it does. And its existence is forcing astronomers to rethink how stars evolve, how binary systems interact, and what secrets dormant black holes might be hiding throughout the galaxy. The universe is full of stars with stories to tell. We just have to learn how to listen, like, share, and subscribe for more cosmic mysteries. And as always, keep looking up.